Section 5 of The Man of Genius by Cesare Lombroso. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Recorded by Leon Harvey. The Man of Genius, Part 2. The Causes of Genius. Chapter 1. Meteorological influences on genius. The influence of weather on the insane. Sensitiveness of men of genius to barometrical conditions. Sensitiveness to thermometrical conditions. The influence of weather on the insane. A series of clinical researches which I carried on for 6 consecutive years has shown me with certainty that the mental condition of the insane is modified in a constant manner by barometrical and thermometrical influences. When the temperature rose above 25 degrees Celsius, 30 degrees Celsius and 32 degrees Celsius, especially if the rise was sudden, the number of maniacal attacks increased from 29 to 50. On the days on which the barometer showed sudden variations, especially of elevation, and more particularly 2 or 3 days before and after the variation, the number of maniacal attacks rapidly increased from 34 to 46. This meteoric sensibility, as I term it, increased in an inverse ratio to the integrity of the nervous tissues, being very great in idiots and slightest in monomaniacs. The study of 23,602 lunatics has shown me that the development of insanity generally coincides with the increase of monthly temperature and with the great barometrical perturbations in September and March. The onset of heat acts more efficaciously, however, than the intense heat which follows, and the heat which has become habitual in August acts much less harmfully. The minimum number of outbreaks of insanity is found in the coldest months. See plate. This coincidence is seen best in the French lunatics studied by Esquirol. The French figures present with most clearness the effect of thermometrical influences, because in France the entry of lunatics into asylums, being little impeded by red tapeism, follows closely on the outbreak. A table is displayed on the page, divided into 3 main columns, with the month, insane divided between Italy and France, and temperature. Now a similar influence may be noted in those to whom nature, benevolently or malevolently, has conceded the power of intellect more generously than to others. There are few among these who do not confess that their inspiration is strangely subject to the influence of weather. Those who associate with them, or who read their correspondence, know that they suffer so greatly from this cause that they often complain to everyone and struggle, with the help of various artifices, against the malignant influences which impede the free flight of their thought. Sensitiveness to barometrical conditions. Montaigne note, si la sante merci det la carte dian bio jour, me voila honet hom. Diderot wrote, Il me semble qui j'ai les spirit faudans les grands vents. Giordani foretold storms 2 days beforehand. Maine de Baran, a very spiritualistic philosopher, wrote in his Journal de Mauvais Intime, I do not know how it is that in bad weather I feel my intelligence and will so unlike what they are in fine weather. And again, there are days in which my thought seems to break through the veils which surround it. In some conditions of the weather I feel delight in good and adore virtue. At other times I am indifferent to everything, even my duties. Are our sentiments, our affections, our principles related to the physical condition of our organs? The study of his journal shows us the justice of his doubts. Let us take 1818. In April, we find 2 periods of good inspiration and 4 of bad, although the weather was fine. In May he was constantly sad, and in November only cheerful during 10 days. 1815. May. I am suffering from the nervous disposition which I experienced in spring, and though wishing to do too much, I do nothing. 23rd May. I am happy because of the air that I breathe and the birds that are singing. But inspiration passes away through the senses. Each season has not merely special forms of sensation, but a certain way of understanding life which is peculiar to it. 17th May. Irresistible pleasure of thought, inspiration. 4, 16, 17 October. Empty of ideas, sad. 1816, 21st January. Sad and idle, my life is useless. 24th April. I am another man. Every day seems a feast day. At this time of the year, something seems to lift the soul to another region and give it strength to surmount all impediments. 1817, 13th of April. Excited. 7 May. Working on Contillac. 18 July. Marvelous activity. 12 October. Am transformed. Thought turns to commonplace triviality. 22, 23, 28 November. Sterile agitation. Alteration of all my mental faculties. 1818. 1st of April. Northerly wind. Am weary, sad, suffering, stolid. 1820, 31st of March. At this time of the year, it always happens to me that body and mind are alike heavy. I have the consciousness of my degradation. 1821, May. At this month I am sad and yield to external causes like a marionette. 21 October. I feel myself newborn. I was returning to work, but the weather has changed. The wind has turned to the south. It is strong and I am another man. I feel inert with a distaste for work, and inclined to those sad and melancholy fantasies which are always so fatal to me. Alfieri wrote, I compare myself to a barometer. I have always experienced more or less facility in writing. According to the weight of the year, absolute stupidity in the great solstitial and equinoctial winds, infinitely less perspicacity in the evening than in the morning, and a much greater aptness for creation in the middle of the winter or of summer than in its intermediate seasons. This has made me humble, as I am convinced that at these times I have no power to do otherwise. Monod says that the phases of Michelet's intellectual life follow the course of the seasons. Pushkin's poetic inspiration was greatest during dark and stormy nights. We catch a glimpse of these facts of an appreciable influence of barometrical conditions upon men of genius as upon the insane. Heat. Thermometrical influence is much clearer and more evident. Napoleon, who defined man as a product of the physical atmosphere and the moral atmosphere, and who suffered from the faintest wind, loved heat so much they would have fires even in July. Voltaire and Buffon had their studies warm throughout the year. Rousseau said that the action of the sun in the dog days aided him to compose, and he allowed the rays of the midday sun to fall on his head. Byron said that he feared cold as much as a gazelle. Heine wrote in one of his letters, It snows, I have little fire in the room, and my letter is cold. Spallanzani, in the Ionian Islands, found himself able to study for 3 times as many hours as in misty Pavia. Leopardi confesses in his letters, My temperament is imbecile to cold. I wait and invoke the rain of Ormuzd. Gaesti wrote in the spring, Inspiration is becoming favourable if spring aids me, as in all other things. Paisiello could only compose beneath 6 quilts in the summer and 9 in the winter. Similar facts are told of Ferrers, Mary, and Aronde. Sylvester tells how, when on board the Invicta, beneath the vivifying rays of a powerful sun, the method of resolving a multiple equation occurred to him, and he succeeded without pen or pencil. Le Sage, in his old age, became animated as the sun advanced in the meridian, gradually gaining his imaginative power together with his cheerfulness. As the day declined, his mental activity gradually diminished, until he fell into a lethargy which lasted to the following day. Giordani could only compose in the sun, or in the presence of abundant light and great heat. Foscolo wrote in November, I keep near the fire, my friends laugh at me, but I am seeking to give my members heat which my heart will concentrate and sublime within. And in December he writes, My natural infirmity, the fear of cold, has constrained me to live near the fire, and the fire has inflamed my eyelids. Milton confessed in his Latin elegies that in winter his muse was sterile. He could only write from the spring equinox to that of the autumn. In a letter he complains of the cold of 1678, and fears that, if it lasts, it will hinder the free development of his imagination. Dr. Johnson, who tells us this in his Life of Milton, may be believed on this point, for imagination never smiled upon him, only the cold and tranquil intelligence of criticism, and he adds the commentary that all this must be the result of eccentricity of character, he, Johnson, never having experienced any effects from the variations of the weather. Pushkin often said that he found himself most disposed to composition in autumn. The brilliant spring sunshine produced on him an impression of melancholy. Salvator Rosa laughed in youth as Lady Morgan tells us in her Life, at the pretended influence of the weather on works of genius, but in old age he became incapable of painting or thinking, almost of living, except in the heat of spring. In reading Schiller's correspondence with Goethe, one is struck by the singular influence which the gentle and imaginative poet attributed to the weather. In November 1817 he wrote, "In these sad days beneath this leaden sky, I have need of all my elasticity to feel alive, and do not yet feel capable of serious work. And in December I am going back to work, but the weather is so dull that it is impossible to preserve the lucidity of the soul. In July 1818, thanks to the fine weather, I am better. The lyric inspiration which obeys the will less than any other does not delay." In December he complains of the necessity of completing Wallenstein, unfortunately coincides with an unfavourable period of the year, so that, he writes, "I am obliged to use all my strength to preserve mental clearness, and in May 1799 I hope to make progress in my work if the weather continues fine." All these examples allow us to suspect, with some probability, that heat, with rare exceptions, aids in the production of genius, as it aids in vegetation, and also aids, unfortunately, in the stimulation of mania. If historians who have squandered so much time and so many volumes in detailing minutely to us the most shameless exploits of kings had sought with as much care the memorial epoch in which a great discovery or a masterpiece of art was conceived, they would no doubt have found that the hottest months and days have always been most fruitful for genius, as for nature generally. Let us endeavour to find more precise proofs of this little suspected influence. Dante wrote his first sonnet on the 15th of June, 1282. In the spring of 300 he wrote the Vita Nuova. On the 3rd of April he began his great poem. Darwin had the earliest ideas of his great work first in March than in June. Petrarch conceived the Africa in March 1338. Michelangelo's great cartoon, the work which so competent a judge as Cellini considered his most wonderful masterpiece, was imagined and executed between April and July 1506. Manzoni wrote his Five Maggiore in summer. Belden's great poem was conceived in the spring. Galileo discovered Saturn's ring on April 1611. Balzac wrote La Cousine Bette in August and September. Pierre Goriot in September, La Recherche de l'Absolu in June to September. Sterne began Tristram Shandy in January. The first of his sermons in April, the first one in Errors of Conscience in May. Giordano Bruno composed his Candilejo in July, and in his witty dedication he attributed it to the heat of the dog days. Voltaire wrote Tancred in August. Byron wrote the fourth canto of Childe Harold in September, his Prophecy of Dante in June, his Prisoner of Chillon during the summer in Switzerland. Christie wrote of Gingilino and Perrault. Here are the only leaves that April has drawn out of my head after 14 months of idleness. Schiller, it appears, from his letters to Goethe, conceived Don Carlos and Wallenstein in the autumn, as well as Fiesco and Wilhelm Tell. Wallenstein's Lager and Letters of Aesthetics in September. Cabale und Liebe in winter. The Magician, The Glove, The Ring of Polycrates, The Cranes of Ibycus, and Nanderweiser's Song in June. The Jungfrau von Orleans in July. Goethe wrote Werther in autumn. Mignon and other lyric poems in May. Cellini, Alexis, Euphrosyne, Metamorphosis of Plants, and Parnasse in June and July. The Exenine, Hermann und Dorothea, Westostlichen Divan, and Natürlich Doktor in winter. In the first days of March 1788, which he wrote were worth more to him than a whole month, he dictated, besides other poems, the beginning of Faust. Salerno's Hymn to Liberty was written in May. Rossini composed his Semerenade almost entirely in February, and in November the last part of the Stabat Mater. Mozart composed the Mithridate in October, Beethoven his Ninth Symphony in February. Donizetti composed Lucia di Lammermoor perhaps almost entirely in September. In any case, the famous Tucci a Dio spiegasti l'Eol belongs to the date, and Figlia del Reggimento was also composed in autumn. Lindergi Chamanox in spring, Rita in summer, Don Pasquale and the Miserere in winter. Wagner composed Der Fliegende Holländer in the spring of 1841. Canova modeled his first work, Orpheus and Eurydice, in October. Michelangelo conceived his Pieta between September and October 1498. The design of the Libreria in December. The model in wood of the tomb of Pope Julius in August. Leonardo da Vinci conceived the equestrian statue of the Sforza and began his book Della Luce delle Ombre in April, for we find in his autograph manuscript these words: "On April the 23rd, 1492, I commenced this book and recommenced the horse." On the 2nd of July, 1491, he designed the pavilion of the Duchess's Bath. On the 3rd of March, 1509, Sir Christopher's Canal. The first idea of the discovery of America came to Columbus between May and June 1474, in the form of a search for the western passage to India. Galileo discovered the sunspots contemporaneously with, or before, Scheiner in April 1611, in December 1610, and even in September, since he speaks of his observation having been made 3 months previously. He discovered the analogy between the phases of Venus and those of the moon. In May 1609, he invented the telescope. In July 1610, he discovered 2 stars, afterwards found to be the most luminous points of Saturn's ring, a discovery which, according to his custom, he expressed in verse: Altissimum planetum tergeminimum observani. In January, he found Jupiter's satellites. In November 1602, the isochronism of the oscillations of the pendulum. Kepler discovered the law which bears his name in May 1618. The discovery of Zwicky regarding Jupiter took place in May, that of Tycho Brahe in November. Fabricius discovered the first changing star in August 1546. Cassini discovered the spots which indicate the rotation of Venus in October and April 1666-67. In October, December, and March 1671, 1672, 1684, 4 satellites of Saturn. Herschel discovered 2 in March 1789. In June 1631, Hevelius conceived the first ideas of selenography. A satellite of Saturn was discovered by Huygens on the 25th of March 1665, another by Dawes and Bond on the night of the 19th of September 1848. 2 satellites of Uranus were discovered by Herschel in 1787. One of them, considered as doubtful by Herschel, was again discovered by Struve and Lassell in October 1847. The last, Ariel, was discovered by Lassell on the 14th of September 1847. On the 8th of July in the same year he had also seen Neptune's satellite for the first time. Uranus was discovered by Herschel in March 1781. The same astronomer observed the moon's volcanoes in April. Bradley discovered in September 1728 the aberration of light. Encke's and Vico's fine observations on Saturn took place in March and April 1735-38. Of the comets discovered by Gambart, 3 were in July, 2 in March, and in May, 1 in January, April, June, August, October, December. The last 3 comets discovered in 1877 were perceived in October, February, and September. In August, Hall observed the satellites of Mars. Schiaparelli's discovery on falling stars dates from August 1866. We regard in Malficki's journal that in July he made his great discoveries in the suprannual glands. It is curious to observe how some 1 month predominates in certain years. For example, January in 1788 and 1790, and June in 1771, during which he made 13 discoveries. The first idea of the barometer came to Torricelli in May 1645, as may be seen by his letters to Ricci. In March 1644, he had made the discovery of great moment at that time of the best way of making glass for spectacles. The first experiments of Pascal on the equilibrium of fluids were made in September 1645. In March 1752, Franklin began his experiments with lightning conductors and concluded them in September. Goethe declared that it was in May that his original ideas on the theory of colours arose, and in June that he made his fine observations on the metamorphosis of plants. Hamilton discovered the calculus of quaternions on the 16th of October 1843. Volta invented the electric pile in the beginning of winter, 1799 to 1800. In the spring of 1775, he invented the electrophore. In the first days of November 1784, he discovered the production of hydrogen in organic fermentations. His invention of the eudometer took place in the spring. About May and April of the same year, 1777, Volta wrote to Barletta the famous letter which he divided the electric telegraph. In the spring of 1788, he constructed his great conductor. Luigi Brugnatelli found out galvanoplasty in November 1806, as is shown by a letter which the advocate Zannino Volta found in the correspondence of his grandfather. Nicholson discovered the oxidation of metals by means of the voltaic pile in the summer of 1800. From the examination of Galvani's manuscripts it appears that his studies on intestinal gases began in December 1713. His first studies on the action of atmospheric electricity on the nerves of cold-blooded animals were undertaken, as he himself writes, at the 20th hour on the 26th of April, 1777. In September 1786 he began his experiments on the contractions on frogs, whence the origin of galvanism. In November 1780 he stated his experiments on the contraction of frogs by artificial electricity. We see by Lagrange's manuscripts, published by Boncompagni, that he had the first idea of the calculus of variations on the 12th of June 1755. On the 19th of May 1756 he conceived the idea of the Mécanique analytique. In November 1759 he found a solution of the problem of vibrating chords. From the manuscripts of Spallanzani, which I have been able to examine in the communal library at Reggio, it appears that his observations on moles began on the 26th of September 1770. On the 8th of May 1780, Spallanzani started, to use his own words, the study of animals which are torpid through the action of cold. In April and May 1776 he discovered the parthenogenesis of certain animals. The 2nd of April 1780 was the richest day in experiments, or rather deductions, on the subject of ovulation. It becomes clear, he wrote on the same day, after having made 43 observations, that the ova are not fecundated in the womb, that the sperm cells after emission remain apt for fecundation for a certain time, that the vesicular fluid fecundates as well as the seminal, that wine and vinegar are opposed to fecundation. Impatience, adds this curious manuscript, which enables us to assist at the incubation of these wonderful experiments, will not allow me to draw any more corollaries. On the 7th of May 1780 he discovered that an infinitely small amount of semen sufficed for fecundation. A letter to Bonnet shows that Spallanzani had, during the spring of 1771, the idea of studying the action of the heart on the circulation. In March 1773 he undertook his studies on rotifera, and in his manuscripts for May 1781 may be found a plan of 161 new experiments on the artificial fecundation of frogs. Geoffroy St. Hilaire had his first ideas on the homologies of organisms in February. Davy discovered iodine in December. Humboldt made his first observations on the magnetic needle in November 1796. In March 1793 he observed the irritability of organic fibers. The prolegomena of the cosmos was dictated in October. In July 1801 Guy Lussac discovered fluoric acid in fish bones. He completed the analysis of alum in July. In September 1846, Morton used sulfuric acid as an anesthetic in surgery. In October 1840, Armstrong invented the first hydroelectric machine. Matteucci made his experiments with the galvanoscope in July 1830, on torpedoes in the spring of 1836, on electromotor muscles in July 1837, on the decomposition of acids in May 1835. He determined in May 1837 the influence of electricity on the weather. In June 1833 he concluded his experiments on heat and magnetism. The reader who has had the patience to follow this wearisome catalogue to the end may convince himself that many men of genius have, as it were, a specific chronology, that is to say, a tendency to make their most numerous observations, to accomplish their finest discoveries, or their best aesthetic productions, at a special season, or in one month rather than another. Spallanzani in the spring, Guesti and Arcangeli in March, Lamartine in August, Carcano, Byron, and Alfieri in September, Malpighi and Schiller in June, and July, Hugo in May, Beranger in January, Bailey in November, Millie in April, Voltaire in November and December, Galvani in April, Gambart in July, Peters in August, Luther in March and April, Watson in September. A more general kind of specific chronology, a sort of intellectual calendar, is presented when we sum up various intellectual creations. Poetry, music, sculpture, natural discoveries, of which the date of conception can be precisely fixed. This may be seen from the following table. A table is displayed on the page of 5 columns, citing the month, literary and artistic works, astronomical discoveries, physical, chemical, and mathematical discoveries, and the total. One observes at once that the most favorable month for aesthetic creations is May, then comes September and April. The minimum is presented by the months of February, October, and December. The same may be observed partially with astronomical discoveries, but here April and July predominate, while for physical discoveries, as well as for aesthetic creations, the months of May, April, and September stand first. Thus the advantage belongs to the months of early heat more than to the months of great heat, as with insanity also. In the same way the months of greatest barometric variation have an advantage over very hot and very cold months. A graph is displayed on the page, titled The Relation to Average Monthly Temperature to Admission of Lunatics to Asylum and to Production of Works of Genius. The graph has 4 lines displaying French lunatics entered, works of genius, average temperature, and Italian lunatics entered. The bottom axis of the graph reads from January to December, and the side column reads an average temperature between 27 degrees Celsius and 1 degrees. If we now group these data according to seasons, which will allow us to include other data in which the exact month cannot be stated, we shall find that the maximum of artistic and literary creation falls in spring, 388, then comes summer with 347, then autumn 335, and lastly winter with 280. The majority of great physical, chemical, and mathematical discoveries took place in spring, 22, then autumn, 15, very few in summer, 10, and only 5 in winter. I have separated astronomical discoveries from physical and other discoveries because their precise dates are less doubtful and therefore more important. We find 135 in autumn, 131 in spring, 120 in summer, and only 83 in winter. Taking these 1,871 great discoveries altogether, we find spring coming first with 541, then autumn with 485, with 477 in summer and 368 in winter. It is evident, then, that the first warm months distinctly predominate in the creations of genius, as well as in organic nature generally, although the question cannot be absolutely resolved on account of the scarcity of data, as regards both quantity and quality. It was, however, in the spring that the discovery of America was conceived, as well as galvanism, the barometer, the telescope, and the lightning conductor. In the spring, Michelangelo had the idea of his great cartoon, Dante the Divina Commedia, Leonardo of his book on light, Goethe of his Faust. It was in the spring that Kepler discovered his law, that Milton conceived his great poem, Darwin his great theory, and Wagner the Flamingo Hollander, as well as his great music dramas. It may be added that in the few cases in which we may follow day by day the traces of the works of great men, we usually find that their activity increases in the warm months and decreases in the cold months. Thus in Spallanzani's journals, and especially during the years 1777 to 78 and 1780 to 81, in which he was undertaking his investigations into molds, digestion, and fecundation, I found 50 days of observation in March, 65 in April, 143 in May, 41 in June, 33 in August, 24 in September, while there were only 17 in December, 10 in November, 18 in January, 17 in July, and 2 in February. If we examine the curious journal of his own observations, which Malpighi kept day by day for 34 years, we find grouping the observations according to months, July coming first with 71 days, followed by June with 66, May 42, October 40, January 36, September 34, April 33, March 31, August 28, November 20, December 13. Out of over 400 observations, less than a fifth took place in the winter months. It appears from Galvani's manuscripts, as examined by Gherardi, that between the years 1772 and 1781, his investigations on irritability, muscular movement, the structure of the ear, the tympanic bone, and the organ of hearing all belong to the month of April, while his work on cataract belongs to March, and that on hygiene of sight to January. It seems, therefore, to be here a remarkable predominance for April, although there is less certainty than in the preceding cases. I imagine the objections that may be made against these conclusions, the scarcity of data, the doubtfulness, the boldness of bringing within the narrow circle of statistics the sublime phenomena of intellectual creation which seem the least susceptible of calculation. Such objections may have weight with those who believe that statistics can only deal with large numbers, perhaps more remarkable for quantity than for quality, and who thrust aside a priori all reasoning on the data, as though figures were not facts, subject like all other facts to synthesis, and had not their true value as materials for the thinker. The facts I have brought forward, though not large, are at all events to be preferred to mere hypothesis, or to the isolated statements of authors, the more so as they are in harmony with these latter, and may at least serve as the encouragement of a new series of fruitful psychometric researches. It may be said, also, that the creations of genius cannot furnish great columns of figures. It is very true, however, that in regard to many of them the chronological coincidence is connected with accidental circumstances entirely independent of the psychic condition. Thus, naturalists have greater facilities for observation and experiment in warm months. Thus also the length and equability of equinoctial nights, the difficulty of making examinations on foggy days, the weariness and discomfort experienced on days that are very hot or very cold, largely account for the predominance of discoveries in spring and autumn. Yet these are not the only determining circumstances. In the case of anatomists, for example, bodies may be had at all seasons, and principally in winter, and again, the long and clear winter nights, in which the influence of refraction is less, ought to be as favourable as the astronomers on temperate climates as warm summer nights of northern climates, which give us, however, a greater number of astronomical discoveries. It is well known, also, that accidental circumstances influence even the phenomena of death, birth, murder, when closely considered statistically. If, however, all these phenomena conduce to the same result, we are led to infer a similar cause common to all, and this can only be found in meteorological influences. I have grouped together aesthetic creations and scientific discoveries because they are associated by that moment of psychic excitation and extreme sensibility which brings together the most remote facts. The fecundating moment, which has rightly been called generative, a moment of which poets and men of science are nearer than is generally supposed. Was there not an audacious imagination in Spallanzani's experiments, in Herschel's first attempts, in the great discoveries of Leverrier and Schiaparelli, born of hypothesis, which calculation and observation transformed into axioms? Littrow, speaking of the discovery of Vesta, observes that it was not the result of chance, nor of genius alone, but of genius favoured by chance. The star discovered by Piazzi had glimmered in Zach's eyes, but he, with less genius than Piazzi, or in a moment less perspicacity, attached no importance to it. The discovery of the solar spots only needed time, patience, and good fortune, remarks Secchi, but it needed genius to discover their true theory. How many learned natural philosophers, observed Arago, in going down a river, must have observed the fluttering of the vane at the masthead without discovering, like Bradley, the law of aberration? And how many artists, one might add, must have seen hideous heads of porters without conceiving Leonardo's Judas, nor oranges without creating the cavitella of Mozart's Don Giovanni? There is, however, one last objection which seems more serious. Nearly all great intellectual creations and all discoveries of modern physics are the results of the slow and continuous meditations of men of science and their predecessors, so that they form a kind of compilation, the chronology of which is not easy to define, because the date at which we are arrested indicates a moment of birth rather than of conception. This objection, however, may be applied to nearly all human phenomena, even the most sudden. Thus fecundation is a phenomenon which depends on the good nutrition of the organism, and on heredity, insanity, death itself, though apparently produced by sudden, even casual circumstances, are yet related on one side to the weather and on the other to organic conditions, so that often one may say the precise date is fixed at birth. End of The Causes of Genius, Chapter 1. End of Section 5.